last of the adult events for the adult summer reading program. Tonight's program is Stargazing Basics. And our guest is Brent Studer. He's adjunct faculty of astronomy at Kirkwood Community College. And he's going to lead us through, you would think stargazing would be simple. Trust me, it's you can see it, but to know what you're doing. So he's going to give us all a lesson in stargazing. We are going to turn down the lights so that we can see the program. So we're going to do questions after the program. And in order for the questions to be heard on the audience who's watching from home, they have to be done through a microphone. So I'm going to walk around with the microphone. So if you have a question after the program, just raise your hand, and we'll go from there. So, Brent, it's all yours.
All right, did I get the microphone on? Or?
Yep,
okay, perfect. I had to hit the switch behind my back. So, thanks for coming tonight. I appreciate everybody coming here, and hopefully I'll give you some new information, or if you're a little bit familiar with stargazing, hopefully I'll give you a little bit more information to make your looking at the sky a little bit more enjoyable. So I've tried to cover quite a few different topics here. A little bit of what's visible through the summer and through the fall, but I wanted to give a little bit of an overview of some of the other things that would be very helpful. And really the most helpful thing for sky gazing is your eyes. You don't need any real special equipment, but it is helpful to have a few things to help you learn your way around the sky. I mentioned a monthly star chart, and actually I do have a copy of the August sky up here, so I do have some star charts up here. You can take a copy of those. There's a few other brochures too for the Cedar Amateur Astronomy Club, which I'll show you and talk about in a few minutes. So having a good star chart or a map of the sky, or one of these devices that's called a planisphere. These are the devices that have the dates and times around the outside, and then the inner wheel rotates. So you can turn the inner wheel to show you which part of the sky is visible on a particular date. We also always recommend, when you're going outside, to use a red flashlight. When we're in the room like we are right now, your eyes aren't adapted to the dark. So we'll probably turn the lights down a little bit for some of the slides, but to really get your eyes totally adapted to the dark, you would need to have a red flashlight, because the red light does not ruin your night vision. And that's something that you probably have seen in old movies, or maybe you might have known somebody that worked in a darkroom, developed their film, and so they can actually see when they're working in a darkroom, but it doesn't ruin the exposing of the film, or it doesn't ruin their night vision either. So we always recommend a red flashlight, and then of course your eyes. We'll talk about a few other things that are helpful also. Oops. Okay, and as I mentioned, some sky maps or a planisphere. So these are a couple of the places where you can get the sky maps. In fact, the one that I have printed off is from a website that is called telescope.com. In fact, it's printed, or you can print it off in color if you choose, or you can print it in black and white. And I just printed off the black and white version to give you tonight, but you can do either one of those, and you can choose the current month or the next month. And they also have what's visible in the sky that particular month. And telescope.com is actually a website that goes along with a company that's named Orion Telescopes and Binoculars. I'm not going to push anything that they sell, but they do sell some really nice equipment, whether it be binoculars or telescopes or star charts or things like that. But they do give these monthly sky charts away free, just going to their website at telescope.com. Another one that is free is this one that you see in the back up there, which is also printed as a white background with a little bit of the Milky Way going across it, and then some of the things that are visible on that particular month. And that's from a website that is skymaps.com. Again, completely free. If you like, I know skymaps.com has a button where you can donate some money to keep the site running through PayPal or something like that. But the sky maps are free. They do sell books and other sky gazing aids if you'd like to buy those, but the charts themselves are free. And the one from Sky Maps has a front and a back, so you can print both sides. The back side has a little bit more information about observing some of the specific things that are visible that particular month that might be listed on the front. So there's just a little bit of detail in the back. So getting a chart like that is very helpful, and it's nice that they're available for free. Oops. Okay, sorry about that. I actually hit the wrong button. Sorry about that. Okay. And I also mentioned these things that are called planispheres or star finders. And these are the type that have the cutout, which shows what is visible in the sky right now. And you can see that it's got different directions pointed around it. So it might say east, south, north, and west. And then you rotate the wheel so that the date and the time that you're outside actually line up. And then what is visible through the wheel is what you'll be able to see when you hold that up overhead. And you can buy the planispheres. Here's a fairly nice one that I have. So you can buy those. They're often available around town, or you can find them at places like telescope.com. But otherwise, you can get them for free and print them on your home computer too. The one that is up here is actually from the Sky and Telescope magazine website, skyandtelescope.com. I know they have it here in the library. It's the book, or it's the magazine that I recommend. I've been reading it probably since my grade school days. So skyandtelescope.com does have their star wheel, and you can print it off in color. It's 2 sheets, and then you just cut out the outer part of the wheel. You just cut it out, and then you cut out the center, put the 2 together, staple it together. So you can print off one of those from skyandtelescope.com, or there's another one from the Lawrence Hall of Science, and that's a really nice one too. And you can find the Lawrence Hall of Science star wheel, and that is actually named after their emeritus director, who went by Uncle Al, and so it's just uncleal.net. But you can also just Google Lawrence Hall of Science or Uncle Al's Star Finder, and that is another one that you can just print off both sheets. Don't do it front and back. You'll need to have both sheets separate, but print off both sheets of paper, and then you can staple them together after you've done the cutting out, and you've got your own little star finder. And I thought I'd mention a few other more high-tech aids. If you have smartphones and tablets, there's a really nice program that we use in my class, and I know a lot of amateur astronomers use it. It's at the website stellarium.org. And if you want to see what stellarium looks like when you're using it, the slides I've made tonight, when I show you the night sky, they are made with stellarium. So it's a really nice freeware program, and it's available for all platforms. So if you have Linux, Mac, Unix, or Windows, you can get it on any of the platforms. So it's a really nice freeware program. And if you choose to look for an app, maybe for your iPad or your tablet or your smartphone, the one that I use, although there are a number of them, the one that I use is called Distant Suns. There are different versions of it. There's a light version, which is either free or maybe $1.99, and there is a more advanced version, which I think is about $5. So you can get different versions of Distant Suns. And another one that gets very good reviews and is often rated very highly is called Sky Safari. And so that one, again, comes in different versions. You can get the more pro version, or you can get a fairly simplified version if you want to start off with that. So those are 2 very good ones. And one that I actually forgot to put up there, now that I think about it, there's one that's called Star Walk. And that is one where you can actually open up the app, hold your phone or your tablet up, and the GPS in your tablet or your phone will actually show you the sky that would be behind your phone or your tablet. So you can actually imagine looking up there at the sky, and the real sky is right behind it. So there are several of those too that really, really do help. And so that one is called Star Walk. But if you want to start with the very basics and the free ones from uncleal.net or Sky and Telescope, that's a really good way to start learning your way around the sky. And of course, print. I don't want to forget about the good old books. And one of the most famous ones is this book that's called The Stars by H.A. Rey, and that's the book that is right over there. It's been around since the 1950s, and actually he wrote Curious George. He was the creator, the illustrator of Curious George back in the 50s, and he also loved the sky. And what he wanted to do was create the constellations in patterns that might actually look more representative of what we think they are. What we see on the cover is Gemini, the twins. And so he drew the lines to connect the stars to really look like twins. Sometimes star charts would show the constellations, but they wouldn't necessarily look like what the name of the constellation represents. And so Gemini sometimes would maybe be drawn more like like a big, industrial staple or something like that, not even looking like twins. So he drew the constellations with the lines connecting the stars to be more representative and hopefully easier for people to learn to identify. So that's a classic. It's been around since the 1950s. One that includes more information than just the constellations, but maybe a little bit of historical background. Chet Ramo is a professor of astronomy. I think he's retired now. He's written a number of books, and I've read several of his other books. He wrote one called 365 Starry Nights. So that would be a nice one to get. And then also there is the Audubon Guides. And so the National Audubon Society, they have their constellation guides. I remember getting one of those when I was a kid, I think probably in grade school. I went to the library back home, got the Audubon Guide out, and I actually made my own flashcards. That was, an only child, so my mom said, go entertain yourself, go do something, go draw, go read. So I took an old deck of cards and some black construction paper, glued the construction paper onto the back of the cards, and then used white ink, which now you can just go to one of the supply stores, one of the book supply stores like Iowa Book and Supply, and you can probably get gold and silver and other colored pens, but I used white ink and I drew the constellations as they were represented in the Audubon Guide and used them as flashcards to teach myself the constellations. So you might want to try that, or if you have kids or if grandchildren, you might want to try that, but it's a good way to learn the constellations. So the Audubon Guides are great. And then, of course, magazines. I mentioned Sky and Telescope. That's my favorite. Some might prefer Astronomy magazine. They're both available locally, so they're easy to find. And I know Sky and Telescope is here at the library. I don't know if you have Astronomy magazine. I don't recall right offhand, but it hasn't been around as long. Sky and Telescope has been around since the 1930s as the Sky and the Telescope. There were two separate magazines that merged. So they've been around since the 1930s. And then there are tons of books. I always tell my Kirkwood students when it's time to write a term paper, get to the Iowa City Public Library. There's an amazing astronomy section here. It's really, really large, and there's a lot of really good books here. So definitely I would say get to the library also, find the star charts. There's all kinds of them. These are just a few to give you some ideas. But once you start looking, you'll certainly find a lot more of them. And then I mentioned a red flashlight too. And there are different types of red flashlights. A lot of flashlights now are very low energy and they have LEDs instead of light bulbs in them. But as long as it's a red flashlight of some kind, you can buy these. You can also make them. It's pretty easy. I know a lot of amateur astronomers and other people have made red flashlights this. You just take an ordinary flashlight. You can buy the red gelatin film like they might use for theater productions and put them over the big lights in theaters, or just go to a craft store and find a piece of red cellophane of some kind and then put that in front of the lens, or behind the lens, excuse me, and then put the flashlight back together, and then you've got a red flashlight. So they can be made. You might want to put a couple layers of the red in there just to make sure that it blocks out the visible light and lets through only the red. But if you wanted to buy one, you can certainly find those too. Although I know a lot of people will actually just make them by going and getting a piece of cellophane or some kind of theatrical film that you would put over a stage light. And one of the big no-nos at an observatory is to have an ordinary flashlight or to take your cell phone out, because it's amazing how bright a cell phone is. And so you can ruin somebody's night vision for 20 minutes just by taking out a light. It takes your eyes about 25 minutes to adapt to the dark. So once somebody takes out a cell phone, or if they use a regular flashlight to see around on the sidewalk, you can ruin somebody's vision for about 20 minutes. And once your eyes get adapted to the dark, you'll be amazed at how bright the red light actually is. It really is astounding. So once your eyes start getting used to that, you can definitely see very, very easily with the red light. Well, I mentioned your eyes. That's really all you need. And for a lot of the things I'll point out to you in a few minutes, that's really all you need to see the sky. But if you wish to buy a few aids, or if you might already have one, a good pair of binoculars is probably the best place to start. And I always tell my students that binoculars are the best way to start, because if you buy a telescope and decide that astronomy is not for you, you're stuck with something that's a one-hit wonder. There's nothing else you can do with a telescope. They're not even really good for bird watching, because when you look through a telescope, the image is inverted. And you don't realize that when you look at the sky, but many star charts, and photographs are printed with north at the bottom, and then east and west are reversed also. You can buy adapters to change the view through the telescope to be right side up and corrected left to right, but looking through a telescope typically is going to be an inverted view. So most telescopes aren't even good for bird watching. Spotting scopes with special prisms in them, yes, that's a different situation. So I usually recommend starting with binoculars. They're good for all kinds of things if you decide astronomy is not for you, but even if you do love astronomy, you can still take them for all your other hobby activities. And when you look for binoculars, I just mentioned a few different familiar brands. Of course, we have Nikon, the camera manufacturer, and then there's Celestron. Celestron is a manufacturer of telescopes that has been around since the 1960s. Bushnell is a fairly common brand. And then I mentioned Orion, again, Orion telescopes and binoculars. So those are just a few brands. The real important thing to look for, though, is looking for the magnification, the first number, and the diameter of the objective lenses. And generally, we would recommend 7x50s. So that's a 7 magnification. And then each one of these objective lenses are 50 millimeters. 50 millimeters is just under 2 inches. And that's everything in astronomy. The bigger they are, the more light they capture. You're really talking about a bucket that's capturing light, and you want the most light possible coming through that lens. So the light gathering power or the light gathering ability is critical. The other problem you run into, though, is the bigger the glass, because you can certainly get binoculars that have 60 or 75 millimeter lenses, the weight goes up significantly. And once you start getting larger objective lenses, they become very heavy, and you're holding these things up rock steady, and they become very difficult to hold. If you can imagine taking maybe 2.5-pound weights that you might use for exercise, taking 2.5 pounds weights, holding that up and holding it rock steady for a couple minutes. And you may think you're holding it steady, but your hand will be wavering just a little bit. So by the time you look through that eyepiece, the wavering is going to make the star image dance. And that's also the reason we generally don't recommend taking binoculars outside that are larger than 7 power, because that magnification also will make the image dance if you go up to 9 power or 10 or 15 power. You can certainly buy binoculars like that, but they really do need a tripod. And there are adapters that screw into the front of the binoculars, and the adapter screws in right there, and then the binoculars would screw into a camera tripod. So if you go over 9 or go over 7 power, you probably are going to want a tripod. In fact, I've got a 9 power pair that I wish I hadn't bought, because I thought they would be fine. They're not that heavy, but they're 9x60s, and I have to have a tripod. And so that was just not the best choice. They were low price, they were very reasonable, but I probably should have gone with the 7 powers, just because now I need a tripod every time I take them out. And every one of these pair of binoculars that I have up here are all less than $100. Some significantly less than $100, some are less than $50. So you might find them at a department store or someplace around eastern Iowa here, and you can probably get a pretty good deal on some of them. The Orion ones are probably the highest price at just under $100. And the only thing I would recommend about Orion, if you choose to visit their website, is make sure you buy from them. I actually ran across a website that was reselling Orion binoculars for $150. And they are a small company. They don't sell to other stores like Nikon and Celestron and Bushnell might. So if you're finding them at another place than Orion's website, you're probably paying a markup for them. Buy them from them and they'll be cheaper. But all of these are available for less than $100. They will all have multi-coated lenses. They may not be fully coated, but multi-coated means that most of the lens surfaces, particularly the outside surfaces of lenses that are cemented together, the outside surfaces are coated to stop reflections. If they were fully coated, every surface would be anti-reflection coated. That's generally not something you find very often, but it is possible. But at least look for multi-coating on them so that there's anti-reflection coatings on the lenses. And you can generally tell, because if you look at these photographs here, you can see that the lenses kind of look either kind of green or purple, and that's actually the anti-reflection coating. And so if you see a green or a purplish reflection off of those lenses, that'll be fine. What you want to avoid, however, are the ones that have these ruby red or these amber coatings on them. Those actually block a lot of the light and cause a lot of the light to reflect off the lens that you need for night vision. So the ruby and the amber coated ones are not good for astronomy. They may be good for sailing or they may be good for watching sporting events, but not for astronomy. And almost all of these will have this kind of glass that they call BAK4 or BAK7. Those are special types of glass that let more light through in addition to having the coatings that they have. So those are all things that every one of these pair that I have up here are going to have. So any one of them would be a good choice to buy if you wanted to go that route. Okay, well, to get to some of the meat of the presentation, when we talk about looking at the sky, generally we're going to talk about looking at constellations. And constellations I like to describe as really nothing more than counties in the sky. If you think of what Iowa might look like on a road map. Iowa's got 99 counties. They lock together, and every part of Iowa is included within one of those 99 counties. So they are geographic borders that connect the entire land mass of Iowa together, and constellations are the same. They connect the entire sky, and there are 88 modern constellations. And this particular example here shows a constellation called Cepheus, and we see the borders of Cepheus outlined here, so everything in white is within the boundaries of the constellation Cepheus. And it is one of those 88 constellations. And long ago, about the year 1000, an Arabic astronomer by the name of Al-Sufi wrote a book called the Book of the Fixed Stars. And the fixed stars are the stars that we see every night. They stay in the same orientation throughout the night. And he wrote the Book of the Fixed Stars and included constellations as they were recognized in the 11th century. And some of them have names. And so we see that about 200 of the brighter stars have names. Some of them are Greek, many of them are Arabic, and there may be a few more modern ones too. But those are the two main origins of the names. But that includes only about 200 stars. If you go to a nice dark location, you may be able to see through 2,000 stars from a really dark location. And many of them are not named, obviously, if only 200 have proper names. So around 1650 or so, an astronomer by the name of Johannes Bayer started cataloging them and used a system of the Greek letters. And so what he decided was in each one of these constellations, and there weren't 88 at that time, there's only about 60 at that time, but of the constellations that were known, he decided that the brightest star within a constellation would be known as Alpha, the second brightest Beta, third brightest Gamma. So we just went right down the Greek alphabet from brightest to dimmest. But the problem is, at that time there were over 60 constellations, which meant there were 60 alphas and 60 betas and 60 gammas. So how do you distinguish them? So we had to add the constellation name behind it. So for the star that we actually see that is right there, Gamma, it does have a proper name, but it was also the third brightest star in Cepheus, and so it has the letter Gamma to go along with it. It's known as Gamma Cephei because it's in the constellation Cepheus. This one down here, the Greek letter Delta, that is Delta Cephei. There's Alpha Cephei. The other constellations don't have their stars marked by their Greek letters, but in fact, that one right there is actually the North Star Polaris, and that is Alpha Ursa Minoris. So there's an interesting ending to each one of those. It's a Latin genitive ending, which is kind of confusing, but basically it's the Greek letter and the constellation name. And as I always tell my students, if you don't want to remember the Latin endings to those words, every one of the constellations has a 3-letter abbreviation. So if I forget what it is, I can just say Delta Ceph, CEP, or it's Alpha Ursa Minoris, or Alpha UMI. So it's Ursa Minor. The chart that I have represented right here, if you wanted to see every one of the 88 constellations in the sky, you could go to the International Astronomical Union's website. They are the governing body of professional astronomers, and their website is simply iau.org. So IAU is the International Astronomical Union, and they, in conjunction with Sky and Telescope, have created these star charts, or these constellation charts, which I actually use for quizzes for my students. It's a good way to quiz how well they recognize the constellations. Okay, well, kind of getting to what we can see in the next few weeks as we go through the end of summer and start to head into fall. Many of you probably already know how to find the North Star, but I thought I'd go ahead and show it up here. And this also highlights what stellarium looks like, because I created this slide with stellarium. And this represents tonight at about 10:30 in the evening. And here we have the Big Dipper right there. But as you can see, the Big Dipper is actually part of a much larger figure represented right here. And the Big Dipper itself is not a constellation. It's not a specific grouping of stars that is unique and identified as part of its own grouping. It is what we call an asterism. And an asterism is a smaller part of a constellation. The entire constellation is called Ursa Major, the large bear. And so you can kind of see that the figure looks like a bear, but the Big Dipper is nothing more than the hindquarters and the tail of the bear. It's the second largest constellation in the sky. It covers a huge area. And if you're in a dark location, you will be able to see the hind legs and feet, the front of the haunches of the bear, the nose, and then the forelegs. But like I said, it's a very, very large constellation. And if we look just at the hindquarters and the tail, which is our Big Dipper, the two stars at the end of the cup are sometimes called the pointer stars. And those pointer stars point roughly in the direction of the bright star right here. And what we do is we take the distance between the pointer stars and multiply it by 5. And about 5 times the distance between the pointer stars takes you out here to the only bright star in that region, and that is actually the North Star, the star that's known as Polaris. And the real significance of that star is it's not the brightest star in the night sky. That's something a lot of people will assume, is that it's the brightest star in the night sky. That's why it's significant, but it's not. It is significant because if you were to go to the Earth's North Pole, it would be only about a finger's width away from the point that is directly overhead, which is the axis of the Earth's rotation. So if you go to the North Pole and only about the width of your fingernail is how far away the North Star would be from vertical, the point directly overhead, and the Earth rotates on that axis. So the North Star actually represents the point that is very, very close to the Earth's axis of rotation. And if you've ever seen an image of the sky that is a time-lapse photo, you will see star trails circling around. And unfortunately, I didn't grab one of those to put on the slides, but you'd see star trails making a circle, and then Polaris itself swings out a tiny little arc and almost looks stationary. So it represents the axis on which the whole sky appears to spin around Earth. So that's its main significance right now, is it's very close to the Earth's axis of rotation. And it is also the tip of the handle of what is called the Little Dipper, but in fact the Little Dipper is really the constellation Ursa Minor, the small bear. So once you can find the pointer stars, and in late summer as we head into fall, basically this will be west, and if we look at this as a clock face, the Big Dipper is going to be off here somewhere around 9 on a clock face, or swinging down to about 8. So if you think of that as a clock face, off to the west. And if we continue on, this would be something worth looking at. I believe if you continue on, you can go from the Big Dipper, continue the arc of the tail, or arcing off the handle, and continue the arc off of the handle, and that will lead you to a star called Arcturus. And Arcturus is one of those stars that has a name that is Greek in origin. It has been known for thousands of years. And in fact, Arcturus holds a couple interesting facts about it. One is it is the brightest star in the northern sky. So when you look at Arcturus, which you can see right now, it's a spring star, but it is still visible here in the middle part of summer, off to the west. And so we would be looking pretty close to straight west right here, actually. So this will be low in the western sky. It's an orangish colored star, but it is the brightest star in the northern sky, and it just dominates our spring and summer sky. It's at a distance of about 36 light years. So if you go out and look at Arcturus tonight, and hopefully it's clear, you'll be looking at light that is 36 years old. Now, one of the things that was interesting about Arcturus was back in 1933, when Chicago hosted the World of Progress, which was on the 40th anniversary of the Columbia Exposition, because that was the big World's Fair that they had in 1893. 40 years later, in 1933, they had another big World's Fair in Chicago. And it was thought that Arcturus was 40 light years away. So what they decided to do to open up the World's Fair there in Chicago in 1933 was to use the new invention of the photocell and have the photocell tripped by the light of Arcturus to open up the gates to the World Fair. Because they thought it was 40 light years away, they thought that that light had been traveling 40 years since the previous fair there, which was the Columbia Exposition. Unfortunately, it's only 36 light years away, but 40 light years was the best estimate they had back in 1933. So it was used to, at that time in 1933, the other thing that we've discovered about Arcturus, which is a fairly recent finding, is there is a good possibility that Arcturus isn't even a member of our own galaxy, the galaxy in which our solar system and 100 billion other stars reside. We think that our galaxy cannibalized another galaxy, and that's something that galaxies do, especially large spiral galaxies. They cannibalize smaller galaxies. And looking at how fast Arcturus moves through the sky relative to our sun and its chemical composition, it doesn't seem to be a native to our galaxy. It's moving very fast, and it has a different chemical composition than stars like our sun. In fact, Arcturus is moving so fast, you wouldn't tell this from tonight or next, or even 25 or 40, 100 years from now, you wouldn't be able to see Arcturus move that much. But if you were to wait, say, 10,000 years or 15,000 years, Arcturus might not even be near the brightest star in our summer sky or our spring sky. In about another 15 or 20,000 years, it may not even be visible to the naked eye. It's moving so rapidly. But over the course of a few nights or a few decades, it's not that noticeable that it's moving that fast. But astronomers have actually measured that and discovered that it seems to be an interloper from another galaxy. And we think that that's true of a few other stars that are part of what we call the Arcturus stream. But it is a neat star to look at. It's actually part of the constellation Pleiades, and Pleiades sort of looks like a kite or an ice cream cone, depending on how hungry you are, I guess, at the time. And there's what it looks like without the lines. And if you want to continue arcing from the handle to Arcturus, you can then continue swinging on down, and eventually you will find a bright bluish star, whereas Arcturus is more orange color. You'll find a bright bluish star, which is Spica. It is the brightest star in the constellation Virgo. And so once you arc to Arcturus, you can then swing on down towards Spica, and it's visible in the western sky right now. And as it happens, Spica has a neighbor right now, the red planet Mars, which is visible in the evening sky. Mars was actually at its closest approach to Earth back in April when I gave a talk at the observatory up at Palisades, Dallas. But it's still visible in the sky. It'll be setting shortly after sunset, but it's still visible for now. And actually the main difference, I might as well point this out right now, is you can always, at least for our lifetimes, arc through Arcturus and then swing on down to Spica, but Mars isn't going to be there. Mars moves quite rapidly. It's orbiting around the sun just like Earth is, and so Mars moves very rapidly across the sky, as do Mercury, Venus, Jupiter, Saturn, and then Uranus and Neptune. Uranus and Neptune were not known to the ancients, but they knew Mercury, Venus, Mars, Jupiter, and Saturn, and they referred to them as planets. In fact, that's what we call them as planets. They refer to them as Pleiades Aster. Pleiades Aster means wandering star, because they knew the other stars were fixed with respect to each other. They moved across the sky in orderly patterns, but didn't appear to shift from day to day or month to month or decade to decade. But there were 5 that appeared to wander very, very regularly in specific patterns across the sky. And so they referred to those 5 as the wandering stars. Now, in fact, the sun and the moon do that too, but in the evening sky, we have the 5 wandering stars. So the word planet comes from the Greek phrase for wanderer. Well, if we go back to our view of the Big Dipper and the Little Dipper, I have that again right here, and another constellation that we could actually see if we start from the Big Dipper and then use the Little Dipper here. Basically, if you start at the handle of the Big Dipper, cut through the North Star, over exactly opposite from the handle of the Big Dipper will be this constellation that sort of looks like a W. Sometimes it may look like an M or a backwards 3. So it changes depending on the season and whether you're looking at it to the east or whether it's over here on the west at a different time of year, and that is the constellation Cassiopeia. So it's another very prominent northern constellation, and in fact, from the latitude of Iowa, the Big Dipper and Cassiopeia never go below our horizon. So if you've got a clear view of the northern horizon, you'll always be able to see them. They're what is referred to as circumpolar. And so circumpolar constellations and stars never set for a particular observer. So Cassiopeia is always a nice familiar one to see, and it's easy to find directly across from the Big Dipper, and it will never set. It'll always be visible in our northern sky, especially if you've got a good view without trees obstructing your view. And it is part of an entire grouping of constellations that represent the myth, and let's see, I don't quite have it here, but I'll show you a little bit later. The myth of Andromeda and Perseus and the winged horse Pegasus. They're all represented in the sky. I'll show you Andromeda and Pegasus in a few minutes. But Cassiopeia was Andromeda's mother. She was the queen. Andromeda's father was Cepheus. So the king and queen are represented in the sky, but so is Andromeda, so is Perseus, so is Pegasus, the winged horse, and so is the sea serpent that was sent to ravage the country, and Andromeda was then sacrificed or changed to a rock to be sacrificed to the sea serpent. And the sea serpent is Cetus, and that is represented in the sky also. So the whole myth of Perseus and Andromeda is represented in the sky. And I'll show you a few of those stars in a few minutes. But before we get to Perseus and Andromeda, because they're really more of a late summer, early fall group of constellations, here's another group of stars that is easily seen here in the summer. And this is another asterism. It's not a constellation, but it is a grouping of 3 stars, and we call it the summer triangle. Very, very easy to see. In fact, tonight at about probably 9 to 10 o'clock, this star Vega is going to be almost directly overhead. So it cuts almost directly through the point overhead, through our zenith. And we have Vega, Deneb, and Altair, 3 stars that make up something called the summer triangle. Now, they are actually in 3 separate constellations. And I'm not going to show you the borders to show you the official boundaries of the constellations. But Vega is in the constellation Lyra, which is a lyre. It's a small musical instrument, a harp-like instrument. Altair is in a constellation called Aquila, and Aquila is an eagle in mythology. And Deneb actually is the Arabic word for tail, and it is in the constellation Cygnus, which is a swan. A baby swan is called a cygnet. But Cygnus represents a swan in mythology. But maybe even more easy to see is this figure right here, starting with Deneb at one end, going through this bright star, down to this star right here called Alberio, and going across this way. It's much more prominent outdoors, but it looks like a cross, and it's called the Northern Cross. The Northern Cross is actually a small grouping within Cygnus, because actually the wings of the swan extend all the way out here, and so those are the wings of the swan. Deneb marks the tail, and then the long neck all the way down to the head of the swan is right there. So Cygnus is actually flying down the Milky Way, which is what we see right here. So here's our summer Milky Way. That is our galaxy seen from the inside. So we're looking at the disk which is our galaxy kind of seen from the edge on this grouping of stars, and then you can also make out this dark lane of dust and gas that runs through the Milky Way. So easy to see the summer triangle directly overhead. And if we continue on down the summer triangle, here's Altair. So the summer triangle is up above the projector screen. If we continue on down, here we have that great rift, that dark ridge of the Milky Way extending, and then actually the Milky Way gets more prominent down here. And down here we are actually looking towards the direction of the middle of our Milky Way. And when we look towards the middle of our Milky Way, we're looking in the direction of two constellations, and one of them is Sagittarius, one of the zodiac signs, which you probably might be familiar with. And the easiest part of Sagittarius to recognize is this part right here that looks like a little teapot. So we have the body right here, the spout, the lid, and the handle. And so that is a little teapot looking like it's pouring. So that is part of Sagittarius. The center of our Milky Way galaxy is about right in that area, just a little bit off the spout of Sagittarius. And then the other prominent summer constellation towards our southern horizon is this one that actually is one that really looks like its name. This is Scorpius. Right there is the scorpion. And we have the curled tail of the scorpion. Sometimes that's called a fishhook. But the curved tail of the scorpion, and then right at the middle of the body is this brilliant, brilliant red star called Antares. Now in Roman mythology, Mars is the god of war. That's what our planet was named after. So Mars in Roman mythology was the god of war. In Greek mythology, Ares was the god of war. And so Antares is a rival of Ares. It looks just like Mars. Maybe not as bright sometimes, but it is that same kind of ruddy red blood color. So it's referred to as Antares was the name that was given, or rival of Mars. Now, to give you an idea of what some of these stars are really like, just so you have an idea, which is really hard to grasp, but it's kind of fun to look at this. If you can imagine our sun, which is an ordinary star, actually, it's about 700,000 kilometers in radius, which is about 400,000 miles. So our sun is about 800,000 miles in diameter. You could fit 108 Earths across the sun's equator. So fit 108 Earths across the sun's equator. If our sun were a giant gumball machine, you could fit about 1.3 million Earths inside of it. So it's a huge object. But in terms of stars, it's not that big. It's fine for us. It's actually probably better that we live on a planet around a star like our sun, because a star like Vega is 2.5 times bigger. And so Vega's there. It's actually hotter. And when you look up at the stars, you can actually judge their temperatures just with your eyes. Some stars are kind of blue, some are white. Our sun is kind of yellow-white, and some stars are going to be more orangish-red. That's telling us how hot the stars are on their surfaces. So our sun is kind of yellow-white, which means its surface is about, in metric units, we would say that that's about 5,700 Kelvin. That's a little bit less than 11,000 Fahrenheit, to give you a rough idea. So about 11,000 Fahrenheit, or 5,700 Kelvin, produces a brilliant yellow-white light, predominantly. All colors are given off, but the predominant color is going to be yellow-white, or yellow in that part of the spectrum. If we go to a star like Vega, almost directly overhead tonight, is hotter, and it's going to glow more blue-white. Instead of being 5,700 Kelvin, it's almost 10,000. It's almost twice as hot as our sun. So it's blue-white. If we go back to Arcturus, that star that I said is kind of the interloper in our galaxy, it is an orange giant star. It's about 25 times the size of our sun. But it's much cooler on its surface, about 4,000 Kelvin, which is maybe closer to 7,500 Fahrenheit or so. So it's more of an orangish color because it's cooler. If we go to the other star that is in one of the other stars in the summer triangle, the star at the tail of Cygnus, the star Deneb, Deneb is 110 times bigger than our sun. but it's also incredibly hot, and it is also blue-white. I don't remember the exact number, but it seems to me that Deneb gives off about 50,000 times more energy per second than our sun does. So it's an incredibly bright, hot, luminous star. It's what we call a supergiant. But it's only a blue supergiant, a very, very hot supergiant. If we now go to Antares, the rival of Mars, or the rival of Ares, it's what we call a red supergiant, and it's represented right here. And so when we look at Antares, we're looking at a red supergiant, much cooler than our sun, maybe only about 3,000 Kelvin, which is about 6,000 Fahrenheit roughly, maybe a little bit hotter than that. But its radius is about 600 times that of the sun's, which means that if it were placed in our solar system instead of our sun, it would actually swallow all of the planets out to including the orbit of Mars. So that is why it's called a supergiant. And it is so large that the surface is cool, even though the center is incredibly hot, because the surface is farther away from the center than the entire radius of Mars's orbit, which, as it says in this figure, is about 227 million kilometers. So that kind of gives you an idea of the range of sizes of stars that you look at the night sky. And it's pretty amazing that your eye is really a thermometer in a way, because your eyes will tell you the temperature of stars just by their colors. It's different than the faucets at home, because blue means cold and red means hot on your faucets. When we look at stars, because they're giving off light, the redder they are, the cooler they are. The bluer they are, the hotter. And a medium temperature star is one that's kind of in the middle, more yellowish. Okay. Well, I wanted to point this one out here too. This is a little bit harder to see. Here are some of these borders of the constellations right here. So I wanted to show you some of these borders because this is kind of an interesting little anomaly. And it shows you Sagittarius, the little teapot right here, and the hook that is the tail of the scorpion. But I wanted you to look at this line right here. This line is the ecliptic, and that comes from the word eclipse. The ecliptic is the line on the sky on which eclipses can occur, because it is the line that represents the sun's path on the sky. And occasionally the sun and the moon intersect and produce eclipses. So here we have the ecliptic, but the reason I like to point this out, and it made a big stir in the news a few years ago, is because an astronomer at the Science Museum up in St. Paul mentioned that there are 13 signs of the zodiac, not 12. And that's because from roughly the time of Thanksgiving to about the second week of December, the sun actually skirts through this region right here, which is not part of Sagittarius, and it's not part of Scorpius, but it is actually part of this much larger constellation called Ophiuchus. So Ophiuchus is the 13th sign of the zodiac. And so if somebody asks you what your sign is and your birthday is around the 1st of December, you're an Ophiuchian, which nobody knows that. But there are 13 signs of the zodiac, and that's been true for thousands of years, actually. But the boundaries when they were constructed in modern times have included that 13th constellation to be one of the 13 that the sun crosses through over the course of an entire year. And if we go a little bit further to the west, the next constellation over, which you might know if you know your signs of the zodiac, is Libra. So Libra is before Scorpius. Libra actually used to be the claws of the scorpion, but it was, since ancient times, separated off into its own constellation. But the reason I wanted to point that out is that we have Mars in Virgo near Spica. Mars is ruddy orange color. And if you go between Mars and its rival Antares, about halfway between the two right now is kind of a creamy white steady light that is the planet Saturn. And you'll be able to tell the planets from the stars because the planets are not going to twinkle. The planets are close enough that through binoculars and certainly through telescopes, they present tiny little disks. They're not points of light. And those points of light that are the stars, they actually dance in the turbulence of our atmosphere. And so the stars' image dance just like looking at a coin at the bottom of a pool. And so the star's image dance because the light is scattered as it comes through the atmosphere. The bundle of light from the planets is big enough that that dancing isn't as noticeable, and so they appear to be steady lights. So you'll notice the steady glowing light of Mars and then Saturn. Those are the two planets that are visible in the night sky right now. And if you're more of a morning person, if you get up about 5:30 in the morning and you look out to the east, you'll just see the moon tomorrow, but also you will see the brilliant planet Venus, and then you might actually glimpse the planet Mercury. Now, Mercury is a little bit tricky to see because it's very low on the horizon, but if you know where Venus is and if the moon is up there, and if you see the familiar constellation Orion, and particularly its 3 belt stars will be climbing straight up from the horizon, you might be able to go off of the shoulder star of Orion, or maybe come straight across from the belt, and you might see a faint star, which is actually the planet Mercury. And if you go further on over, the 2 stars that are near the horizon, one on top of each other, are the 2 bright stars in the constellation Gemini. Castor and Pollux are the name of the twins. The other reason I wanted to show you this is if we look at the next slide, which doesn't have the lines on it, later on this fall, you will start to see this little group of stars rising at about 10 or 11 o'clock in the evening, and that little group of stars is called the Pleiades, or the 7 sisters. So it looks like a tiny, tiny little teardrop, and it's got a little bit of fuzziness to it. So if you see that tiny little teardrop, it always rises in the fall, around 10 or 11 o'clock at night as we start going to September and early October. And then we'll also see this brilliant V, and this V with a bright red star at one end marks the face of the constellation that is Taurus the Bull. So seeing that face of Taurus and seeing the Pleiades is a sure sign that fall is coming. Through binoculars, the Pleiades is a beautiful little cluster. You might see 6 to 7 stars with your unaided eye, but through binoculars you can see dozens of them, and they just sparkle like blue jewels. So it's a really pretty little cluster. It's actually about 450 light years away, but it's a pretty little cluster. It easily fits into the view of binoculars or even a low power setting on a telescope. Okay. Well, I wanted to show you this one too because this is actually mid-August. The one that I showed you just a second ago was tomorrow morning. But in mid-August, notice that the stars will have shifted a little bit. That's because one thing most people don't realize is that the Earth doesn't rotate once every 24 hours. That's easy to make a clock that has a 24-hour cycle and has 24 equal units for the hours, but the Earth actually rotates once every 23 hours, 56 minutes, and 4 seconds, and some decimals after that. But it's 23 hours, 56 minutes, and 4 seconds. That's about 4 minutes short of the day. So if you go out and you watch a star, and you notice that star rises at 10 o'clock tonight, tomorrow night that star is going to rise 4 minutes earlier. The next night, 4 minutes earlier. The next night, 4 minutes earlier. By the end of a whole month of 30 days, 4 minutes per night times 30 days is 120 minutes. That star is going to rise 2 hours earlier at the end of the month than it did the first night of the month. And so that's what this slide is representing right here. This is basically 3 weeks from now. So notice that at the same time of day, 5:30 in the morning, Orion is way up there. It's not hugging the horizon right now, but it's shifted because it has been rising 4 minutes earlier every night. Now we actually see that Mercury's gone. Mercury's a wanderer. It's completely gone now. Jupiter has now joined Saturn in the sky because it's now it's a little bit shifted from the earlier view. But the reason I wanted to point this out is if we go from the belt stars of Orion, and this is basically the middle of August, you come to the brightest star in the night sky called Sirius. And Sirius is the brightest star in the night sky, but what is important about this time in mid-August is that Sirius rises just before the sun does. And so it's rising just before the sun, and that is what is called a heliacal rising. Helios refers to the Greek god of the sun. And so a heliacal rising means that the object is rising with the sun, or just before the sun. That was incredibly important to the Egyptians because they knew that when Sirius rose just before the sun, the rainy season would begin and the Nile would flood. And so they knew the Nile would be flooding at that time because the rainy season would begin. And if you want to look at what also happened, thousands of years ago, that heliacal rising meant that once the flood water subsided, all the cropland, all the fields had to be resurveyed. Well, that actually gave rise to geometry, because one of the earliest uses of geometry was determining the boundaries of the fields. And so, geometry was very, very helpful to help determine where the fields were located once the floodwaters had subsided. And so Euclid wrote, the elements of geometry, and that was actually very useful to the Egyptians once those floodwaters subsided. Okay, well, one last thing here, and I wanted to talk just a little bit about the meteors, because I know that's one of the things to actually see. There is a meteor shower coming up. Unfortunately, this month is not, or this coming month is not going to be great, but I still encourage you to get out there and look. Meteors are really nothing more than specks of dust. Specks of dust that are coming into the Earth's atmosphere anywhere from 50 to 170,000 miles per hour, and those tiny little specks of dust vaporize from friction with the atmosphere. And so they vaporize from friction with the atmosphere, and they vaporize at altitudes of maybe 35 to 45 miles. And they vaporize in just a fraction of a second. And on an ordinary night, you might see 5 or 6 meteors just randomly occurring across the sky as bits of dust enter Earth's atmosphere and vaporize. But several times a year, Earth will actually cross through the orbit of a comet. And a comet is a body of ice and dust that evaporates as it approaches the sun. Halleys Comet is the most well-known. And when the comet approaches the sun, the ice begins to evaporate, the dust is freed up, and so the dust begins to scatter along the entire orbit of the comet. And sometimes Earth actually crosses through the orbit of a comet. And when that happens, we see more meteors per hour, and the effect looks more like this. It's like driving in a snowstorm, because Earth crosses through the stream of dust, and it's like looking at all the snow coming towards your headlights when you're driving in a snowstorm. All the meteors appear to radiate from one part of the sky, the part called the radiant, and the radiant is named after the constellation in which that radiant is located. And instead of seeing just 5 or 6 per hour, you may see 1 or 2 every couple minutes. And so meteor showers are really a great time to go out and look, because it's a much higher likelihood that you'll see some meteors, even some really bright ones. And all you need is a dark sky. Let your eyes adapt to the dark. Like I said, 20 to 25 minutes. A comfortable lounge chair or a blanket to lay down. You don't need any optical aids at all. Binoculars and telescopes are useless because you want to see the whole sky at once. So you just need to lay down where you can see the whole sky, get a blanket, maybe some bug spray, some snacks, and be patient, because it'll take your eyes about 25 minutes to adapt to the dark, and then hopefully you'll see a meteor every couple minutes. And like I said, unfortunately, the most famous one in the summer, called the Perseids, because the meteors appear to be coming from the constellation Perseus, peaks when the Earth crosses through the dust stream about August 12th every year, but unfortunately the full moon is on the 10th this year, which happens every couple years. So you can still see the brighter ones. You're just not going to see nearly as many. You may not see 90 per hour from a dark location, but you still will see some good bright ones. I would still get out there and look. But the other opportunity, one of the better ones after the Perseids, and some may say even a better shower, is one that occurs in December. And that is one that's called the Geminids. So the meteors appear to come from the constellation Gemini. And when they come from the constellation Gemini, the nice thing about the Geminids is Gemini rises at sunset and is visible all night long through December, whereas Perseus is very low in the horizon in August, gets high overhead, probably about 3 o'clock in the morning. So you got to step pretty late to see the Perseids. Whereas the Geminids, you can watch all night long, and the nice thing about it is you have longer nights and shorter days. So you don't have to wait for 10 o'clock when it gets dark, and it's going to start getting light at 5:30 in the morning. So you've got much longer nights, even though it's colder. That also means the air is clearer, and probably going to be maybe less humidity, and so you might have actually still clear air when it's very cold. So that's actually the good shower to observe. Some people say it's actually better than the Perseids, but it may be the one to look for. But all this information will be available to you too, so we'll make sure that that's there. But I would say definitely look for the Geminids, but you might want to try the Perseids just for an opportunity also. Okay. And I might have actually had another slide there, but I think that's probably a really, really good place to end, because I know I wanted to end it with some of the things that you can see, and the meteor showers are always kind of spectacular. So.
Okay, before we start with the questions, I'm going to turn the lights up and grab the microphone.
And don't forget to grab any handouts up here too. I do want to mention that I've got the star charts here, and we do have little calendars here. These actually are put together for the Cedar Amateur Astronomy Club, and they actually have an observatory that is your Halleys Comet. And so if you go to their website, which is listed on here, you can actually get a map that shows you how to get to the observatory there. And these are the list of the public nights in which they have presentations. And so they have 12 nights during the year in which there are presentations, sometimes twice a month. There are no presentations during the winter months because travel is kind of tricky. So between March and November, there is at least one, if not two, presentations a month. But then the observatory now this year is also going to be open on the other Saturday nights that are clear, starting at dusk. So even though there won't be presentations on those other Saturday nights, you're still welcome to go up there, look through the telescopes, talk to the club members, learn a little bit about observing. So you're welcome to pick up those, and if you also would like, there are handouts here, which are the brochures for the Astronomy Club, for the Cedar Amateur Astronomers, and it actually has a little bit of a map on the back, and it also has the contact information. So please be sure to grab one of those if you'd like. So.
Well, you just took my one really killer question, was when can we come to the observatory? So.
Well, I can tell you the date. It's actually this Saturday. This Saturday is the next one coming up.
And what time do you guys get there? What time is a good time to show up?
Let's see. Well, the actual presentation is going to begin at 9 p.m. because we have to wait for the sky to get dark. So the presentation begins at 9 p.m. I usually go out there probably about a half hour, 45 minutes before that. So a lot of times I'll get out there about 8:30. It's kind of nice actually to drive out there when it's still a little bit light. There's a lot of deer, and that's always one thing I warn people about is watch for the deer, because you do have to go on a country road to get to the observatory. So you usually try to get out there about 8:30, but I know people will be there before that too. I think some of the members will show up a little bit before that, maybe at 8 o'clock or so. But the presentation starts at 9. If it's clear afterwards, there will be observing through the telescopes after that. So hope for a clear night. But then there are other opportunities coming up in August all the way through November.
Questions?
So what is the presentation on this coming Saturday? Is it the sky that you see?
That's a good question. I might actually, do you know, Scott, right offhand? Oh, cool. That's a great topic. That's one of my favorites. So this will actually be on supernovae, and supernovas are the massive stars, and I showed you Deneb and Antares. Antares is a prime candidate for ending its life in a colossal explosion. We call it supernova. Very soon. Typically when stars evolve, when they go from that blue supergiant stage to the red supergiant stage, they swell up from blue supergiants to become red supergiants, and that means they're getting towards the end of their life cycles. Relatively speaking, it's a long time. It may be millions of years, but supernovas are the cataclysmic explosions produced when supermassive stars run out of fuel, and there's an implosion that occurs deep inside the star. And that implosion actually then triggers the explosion that we see as this brilliant flare-up of these massive supergiant stars.
So is a shooting star, just a solitary shooting star, is that a meteor that you're seeing?
You are exactly right. That's absolutely right. If you say a shooting star or a falling star, it's really not a star at all. It's really just a small speck of dust entering Earth's atmosphere and then vaporizing from the friction with our atmosphere.
But it's not an organized one like the shower, it's just an individual.
Most likely. Now, it could very well be that if you go out and you happen to see a shooting star or a meteor, it's possible you might actually see a meteor that is part of a shower, and you just know there was a shower going on at that time. So it's quite possible that one of those other dates, for example, maybe you happen to see one sometime around the 1st of June, and maybe it is actually part of that Arietids meteor shower. You wouldn't necessarily know that unless you saw several other ones that all appeared to come from the same part of the sky. But if you see several outside one night and one shoots across the sky towards the east and another one shoots off towards the southwest or something like that, those are going to be two random or what we call sporadic meteors. The meteor shower ones, if you look at them and if you were to trace their paths on the sky, they would all trace back to a common point. But just seeing one at a time, it's probably sporadic unless it's around the date of a meteor shower.
You mentioned the chemical composition of Arcturus. How do they know what the chemical composition is?
That's a great question. That's one of the brilliant discoveries of the 19th century. It actually really gave rise to the birth of what we would call astrophysics versus astronomy, and that is because two scientists, one of whose name you may know, the first one is, his name is Gustav Kirchhoff. Most people may not know Kirchhoff unless you might have taken an engineering class or a physics class and you had to make circuit diagrams and knew Kirchhoff's laws. But Gustav Kirchhoff and his partner, Robert Bunsen, who created the Bunsen burner, they discovered that the powders that early photographers used, they would use powders to make a flash. They discovered that when you looked at those powders and separated the flash, the light that was flashing, separated it out into a spectrum, you could see sharp individual lines. And so you would see these bright individual lines. You wouldn't see the whole rainbow, but you might see red and you might see green and two blue and a purple. They noticed those sharp lines and they realized that each element on the periodic table produces a different pattern. Each element has a fingerprint that has a unique spectrum. And not only did they discover these powders produce unique spectra and they could identify the chemical composition of those powders, they then looked at the sun and they separated the sun's light just like Newton did with a little prism, except they had a more powerful they had a little microscope to look at the prism, and they noticed that the spectrum separated out into colors, but they had dark bands in them. And they found that the dark bands exactly corresponded to the light stripes that the powders produced. So it was basically a negative, but it allowed them to figure out the chemical composition of our sun, because they realized that those dark bands corresponded to the same bright lines of those different elements. And so astronomers actually do that. It's called spectroscopy. And they can look at the light from a star, separating it out using a prism, and when they see those dark lines, they can identify all the unique chemical elements that are inside the star. And they see that Arcturus has a different abundance of those elements than our sun and its fellow stars do. So. Yes?
I'm going to be going to the North Shore Lake Superior next week.
Oh,
and,
lucky you.
That's great for stargazing.
Yeah.
Where would I look for Perseids? And would that be one of the resources you mentioned, the Sky and Telescope? Or?
Yeah, you could definitely look for the August issue of Sky and Telescope or Astronomy Magazine. The nice thing about Sky and Telescope, for sure, is they always publish well over a month in advance. And so their August issue comes out in late June or first week of July. But you could look at the August issue, or you could just go to their website, skyandtelescope.com. They actually even have an app that's called Sky Week that you can download, a little free app that tells you what's in the sky that week. But what you would want to do is, Perseus is actually going to be low in the northeast, about 10 o'clock, shortly after sunset and it gets dark. It's going to be low in the northeast. That means that the only meteors you're going to be able to see early in the evening are going to be the ones that are coming towards the west up over the horizon. The ones that are going east are going to go below the horizon. So you're going to get a limited view. For that reason, it's better to wait as Perseus gradually swings up overhead as the Earth rotates, and by about 2 or 3 in the morning, Perseus is going to be directly overhead. So after midnight is the best time, because after midnight you're going to get Perseus high enough in the sky that you're going to get a shot of seeing the meteors that are going off to the east also. That's the other reason the Geminids are maybe a little bit better, because you have longer nights, whereas you have to kind of wait till midnight or after to get the best view of the Perseids. Now, in this particular case, because the sun is, or the moon is full on the 10th, the problem is this moon is going to be up almost all night long, so there's only going to be just a few hours when the moon is not going to be visible that will allow you to observe. And that's going to be a couple hours of that least favorable time, say around 10 to midnight, when Perseus is still low. But you don't necessarily have to look at Perseus. It's just that the meteors that are coming from the shower will be streaming across the sky to the west, or maybe down to the south or along the northern horizon. So they won't necessarily look like they are in Perseus, but that's where they would have their origin. But you could easily see them going off to the southeast or maybe to the northwest or something like that. But yeah, that'll be a good place to observe, definitely, but you probably get your best observing just a couple hours after sunset before the moon rises, because it'll be pretty bright after that.
I have two questions. In regards to meteors, when you see them as a ball of fire instead of a streak of light, does that just mean that it's a bigger piece of dust?
That's right. Actually, I didn't even think about it. I have a couple of meteorites at home. Meteorites are the remains that hit the ground. So a meteor burns up in the atmosphere. There may be some dust that actually falls to the ground eventually. In fact, about 300 tons of dust a day falls to Earth. And it's washed to the ground as rain. In fact, raindrops can form around that little seed of the vaporized dust. But when you see a brighter one, generally we call those a fireball. And those are the ones that you might see on TV where they light up the whole sky, or somebody catches one on a video camera. That really may be nothing more than a pebble the size of a pea. And so if it's about the size of a pea, it makes this brilliant fireball that could outshine the full moon. It probably will still vaporize in the atmosphere, fall as dust. If the rock was maybe as large as your fist when it entered the atmosphere, then it may fragment, but some of those fragments are probably going to make it to the ground as a meteorite. But yeah, the fireball is actually nothing more than just a pea-sized instead of a dust-sized meteorite, or meteor, excuse me.
Okay, and then when you were mentioning the different colors of stars and you were talking about blue ones and yellow ones, are there also green ones, or are there other colors as well?
That's an interesting question, because I remember reading that as a kid, and it was in one of Isaac Asimov's books, because there really aren't green stars. And people have often wondered why we don't see green stars. We do see, they're all going to be overall white, but some are going to be kind of reddish white, some orange, some yellowish, some pure white, some blue, and some more purplish white. And it all depends on where their energy output peaks. Now, in fact, our sun's energy output peaks in the green. But even though our sun's energy output peaks in the green, there's about an even distribution of violet, blue light, and orange and red light. So they kind of balance out to give us white overall. So we don't exactly know why there are not green stars. It could be because the spectrum peaks in that part and evenly distributes between violet and blue and orange and red. Someone else, I've even heard a speculation one time that it's because the human eye adapted under the sun, which peaks in the green, and so it's just something that our adaptation has not made us sensitive to. I suspect it's probably more of the even distribution of the other colors that cancel and give more of a white light. But I have never seen an example of a green star, although there may be some that have dust around them and things like that that could artificially color them.
Okay, I've got one for you. How do you tell the difference between seeing a meteor and seeing a satellite?
Good question. Actually, I might even have, I don't know if I have a slide of that or not. Let me see if I do. Because you're right, that's a good question. And there's actually one that you could actually see tonight, I believe. A meteor will be very quick. That's the one way that you can tell a meteor is very, it goes across the sky, it streaks very quickly and is gone in a second or two. Satellites generally will not move that fast. They may be visible for longer. The easiest one to see, which unfortunately is not going to be visible tonight, is the International Space Station. And I can show you a slide in a second on that. But the International Space Station, it travels across the sky, but the International Space Station travels at 18,000 miles per hour, which is a really, really good clip, moving across the sky at 18,000 miles per hour. It's a very steady white light. I often say that it looks like the landing lights of an airplane or one of the helicopters landing at the hospital. It's a pure white, steady light, goes across the sky very quick without a sound, doesn't fade very much, whereas the meteor quickly appears and disappears and is going, 35, 50,000 miles per hour. So much quicker and disappears very quickly. Now, I wanted to mention this one because there's a website called heavens-above.com, which is a great place to get information on when satellites are visible. And two of the more popular ones to observe are either the International Space Station, and I can give you some information on that in a second, or what is called an iridium flare. And iridium spacecraft are communication satellites. There's a whole network of them that were launched, and they are communication satellites, but they occasionally flare because they rotate, and as they rotate, the sun reflects off of the solar panels. And you can get brilliant, brilliant flares. And there's actually going to be one tonight, believe it or not. And so I've got the information up there, and what's really cool about it is that's the star Vega right there. So it's going to flare almost right next to the star Vega, which is part of the summer triangle. And the time that we have up there is 21, and let's see, that is 21:15, which means that's 9:15 p.m. So it's 21:15. You don't want to be late for this because meteors and spacecraft don't wait for anybody, so you need to be early. But this spacecraft will actually not even be visible as it starts crossing the horizon from the northern horizon, and then it will pass near Cassiopeia through Cepheus, very, very near the Little Dipper, and then it will get up to the point almost directly overhead and then flare up. And I've seen these out at the observatory, and it's really amazing. You can be looking up at the sky, and then all of a sudden it's almost like an airplane turns and shines its light on you for about 3 seconds, and it's gone. They flare up incredibly fast and very, very bright. And what's really amazing about this iridium flare is this line right here shows the path of maximum brightness, and it cuts right through Iowa City. Yeah, so we're going to be right on the path of maximum brightness, and it's estimated that the maximum brightness is going to be -8. And astronomers use a scale of magnitude. -8 is going to put that far, far brighter than anything in the sky right now.
Okay, stupid question. On your sky map,
Mhm.
where's up? If I were to look directly up,
Right at the center.
Right
so,
at the
So
center.
you can imagine taking this sheet of paper and holding it right up overhead. And so hold it right straight up overhead. And this is going to be the north. So you'd actually hold it so that this end faces north. And then over here would be your west then. And then that would be your east. And that would be south. So the right overhead is going to be right there. So this is going to be very, very close to just crossing directly overhead.
now I had someone tell me once that the way to see a meteor or a satellite is to pick a point in the sky and stare at it because your peripheral vision will pick up the movement, and then you look toward the movement. So if you're looking up tonight at
15.
whatever that
Yeah.
says,
So get out about
9:15
9:10,
and
but-
25 seconds,
Yep.
you'll be able to see the flash.
You will,
right?
exactly. Yeah. Yeah, so I'm actually going to go out and see this too because that's really pretty amazing. And I've seen these too, and I'm sure so Scott has. They're really, really spectacular. But this one is going to be extremely bright because as the sunlight reflects off of its solar panel, just like when sunlight reflects off of a car window or maybe somebody's glasses or a watch or something, if you're right in the path of that reflected light, it can be really, really bright. And this one just goes right through Iowa City. No, this is gonna be so bright. You don't even have to worry about city lights. If you can get away from street lights and not have something shining right in your face, like the glare from a street light or a light in your home, you don't have to be out in the country because at this magnitude 8 right here, boy, I'm trying to think right offhand how bright that's going to be compared to Vega. It's going to be, wow, that could easily be 100 times brighter than Vega. It's going to be extremely bright. And I also mentioned something about the International Space Station too. So let me go ahead and just show you that slide since we talked about satellites here. Shoot. Okay, just get my slideshow opened up here. Oh, that's not something you'll be able to see quite tonight, but I'll put that. Those are the times from the observatory, so I can leave that up there for you too. The International Space Station is visible within a couple hours, maybe about 3 hours after sunset and 3 hours before sunrise. It's not visible in the middle of the night because sunlight's not reflecting off of it. It's got to be at the right altitude, and the sun has to have set or is getting ready to rise at just the right time so that sunlight reflects off of the spacecraft. So some of these times in military time are early in the morning, and these are the dates, but coming up into early August, we have some really nice observing times. Here's 9:50 in the evening on August 3rd, and the space station is going to be about magnitude -3.4. Now remember I said that glint off of the iridium flare is going to be about -8. Astronomers use a scale where the smaller the number, the brighter something is, and so -8 is smaller than -3. There are no stars at -3. The only object that gets brighter than -3 in the night sky are the moon and Venus. So that's an extremely bright appearance of the International Space Station. And so this is also from heavens above. What you can do going to the website is you can register. They'll never spam you. I've never gotten an email in 10 years from this organization. But if you enter your email address and give a username and password, the nice thing about it is you can save your latitude and longitude. And you can just click through the menu and choose Iowa City, Iowa. It'll put in your latitude and longitude, and then every time you go to the website and log back in, it'll save your location. You can even specify multiple locations if you're going on vacation, or if you're going someplace else, you can look up the location of that city or the park you're going to and save it, and it will give you the information for what's visible at that location. And so you can always change your observing location too, but if you just register like I have right here, this is for Iowa City, and so here's a list of the viewing times of the International Space Station, but many of them are in the morning, but after a while as we get into early August, we'll start to see some evening observing times too. So we have 9:50 in the evening, 11:28 in the evening, 9:02, 10:39. So we'll start to see some evening observing times too as we get later into August.
So it's going around twice? That's the 3rd of August?
It's actually orbiting Earth about once every 90 minutes. And it's just that many of those times it's either during the day or it's at an altitude where sunlight is not reflecting off of the solar panels and we can't see it. So it's going around about about once every 90 minutes.
If anybody wants to write this down, and then they can write it on.
So the one that I think is going to be most favorable is we start getting up here as this August 3rd one, and that means that at 9:50 in the evening, starting in the northwest, it should be visible. It'll move very fast across the sky. It'll reach its maximum altitude at about 9:53, so it's going to be visible for 3 minutes when it reaches its maximum altitude, and then it's going to continue on for another 4 minutes before it disappears. And I'll go back to that slide in just a second, but just like the, oops, sorry about that. That was the wrong slide. Let me go back to this. Oops, sorry. I'm going the wrong direction. Sorry about that. Just trying to get my presentation to open up here.
Now, while you're looking for that, someone pointed out to me a app for Android phones, and it's called Space Junk. And when it's the same, a map appears, you hold it upright, and it says up, and it shows you all the stars. But then it also shows you all the satellites.
Right.
And so far, all I've seen are stars and satellites, but supposedly there's other stuff too. But it's a really fun app, Space Junk.
Yep. Yeah, and unfortunately I have the iPhone, so I don't have the Android store, but there are a number of them out there, and that's a good one. I know even if you go to a website called spaceweather.com, Space Weather is a NASA-run website, and spaceweather.com actually has links to apps that show you satellite passages. Space Junk is another cool one too, because every once in a while, even on Heavens Above, they will show you the locations and the times to observe things like spent rocket boosters and the little supply craft that supply the International Space Station. So all those things are up there, listed too.
What I discovered by accident with Space Junk is if you point it down like you're looking at it, it shoots through the Earth. And
Yep.
it shows you all the stuff going on in the southern hemisphere,
Yep.
and on the below the horizon, all the satellites, and so it's a really fun app.
Yep. And that's the same way with the one that I mentioned that was called Star Walk too, is, it's got an artificial horizon, but if you want to see what's down below you, you can actually look down. It'll show you what's on the other side of the Earth too. So yeah, those apps are very cool. So yeah, I just want to give you a few of them, but you can certainly search the app stores online, and there's tons and tons of other ones out there that I'm probably not even aware of yet.
All right, anybody else have any questions? Oh, one more. Two more.
What's a supermoon?
Oh, I was talking to somebody about that at work. It's interesting because we hear the term supermoon and blood moon, and actually one of the astronomers at the U.S. Naval Observatory said, I kind of wish those terms would just kind of blow up and dry away and blow away. Astronomers really don't use the term supermoon. They may refer to as a perigee moon. The moon's orbit is not a perfect circle. Orbits are elliptical in nature. And so the moon's orbit is elliptical, which means that sometimes in its orbit the moon is closer to Earth, and we call that perigee. Geo, just like geology. So perigee means closest to Earth. The point farthest away from Earth in its orbit is called apogee. And occasionally, because the moon orbits the Earth once every 27.3 days, and it goes through its cycle of phases once every 29.5 days, every once in a while the moon is actually full when it is at perigee. And so what commonly is getting called a supermoon is a perigee full moon. And when that happens, the moon is going to be about somewhere around 40,000 miles closer, maybe 50,000 miles closer than it is on average. And that means it's going to look about 16% bigger. So if you saw two photographs side by side, the supermoon or the perigee full moon would look larger. Likewise, the apogee full moon would look much smaller. What really happens, because the moon is about 16% bigger, is it's going to look a little bit brighter than normal. Most people may not really notice the difference in that, but if you were to compare full moons to each other, or if it's a bright snowy night where you've got a lot of snowfall, you might notice the increased brightness. But that's really what a supermoon is it's a moon that is typically full right at very near the time that the moon is at its perigee, passing its nearest point in its orbit to Earth. So, yep. Good question, yes.
Anybody else? Okay, well, thank you so much. This was a great program, and thank you all for coming.
Thank you, I appreciate it. Thanks very much.